Good afternoon, flippers, and welcome back to Geometry Regents. I know you're so excited to have your first flip video of the new semester. I am too. So, today we are going to be doing video 5.1. Our unit title is Code Crafts, even though it looks like Code Cats, it's Code Craft. And our objective for today is students will be able to use properties of triangles to create quadrilaterals. What are those things? You will find out. And our IXL skills are in 2. So, let us review what a triangle is. We know it looks like this. A triangle is a closed figure with 3 sides. 1, 2, 3. And we also know some properties, which are that all the angles sum to 180. All the interior angles sum to 180. And what I just drew would be an example of 3 congruent angles, but they don't have to be. It depends on your triangle. Next, let's go over what a polygon is. So, any type of two-dimensional shape is a polygon. So, anytime we have 2 dimensions, not just length, but also not a 3-dimensional shape. And so a triangle is an example of a polygon, but polygons are general terms. They describe any type of 2-dimensional shapes, and they are made up of straight lines, and the shape must be closed, so all the lines connect up. So any shape, really, with 3 or more sides. What is a quadrilateral? A quadrilateral is a 4-sided figure, so it is a type of polygon, but specifically has 4 sides, and they must be closed. So, for example, a rectangle or a square or any other type of figure with 4 sides. So, a quadrilateral refers to not just a square, not just a rectangle, but any of these shapes that have 4 sides. And there are specific types of quadrilaterals, which we also need to learn the names of, and they have certain properties, which we will learn soon. Some properties of a quadrilateral. So, you can sum the angles in a quadrilateral. And we know you can use the fact that the sum of the angles in a triangle are equal to 180 degrees. We know that. So, and we can use that to prove that the angle sum of a quadrilateral is 360 degrees. So, let's look. If we have a triangle, A, B, C, we know that A plus B plus C, so the angles A, B, and C added together are equal to 180. Let's take another triangle. Let's take 2. So we have this triangle, and we have this triangle. And let's say this one's DEF, and this one is ABC. We know that ABC is equal to 180. We know that DEF is also going to be equal to 180. Therefore, if we put those things together, the whole thing is equal to 360. So if you put 2 triangles together, like you see in this square, we know that the sum of all the angles is 360. So a quadrilateral, the angles always sum to 360 degrees. Here you see it represented again. So just to reiterate and explain one more time, to find the sum of the interior angles of a quadrilateral, divide it up into 2 triangles, as you see here, the purple and the red triangle. There are 2 triangles. And because the sum of the angle of each triangle is 180 degrees, we get 180 plus 180 equals 360. So the sum of the interior angles of a quadrilateral is always equal to 360 degrees. Example problem 1. What is the sum of all the interior angle degrees of the polygon to the side? Well, we're looking at it, and I count that it has 1, 2, 3, 4 sides. So I know it's a quadrilateral, and I can also draw 2 triangles. So I know 180 plus 180 it's equal to 360. Or I could just look at it and know that it's a quadrilateral, so I know it's 360. That's pretty easy. 360 is your answer. Second problem. How many triangles does it take to create a quadrilateral? Well, that's just working backwards. So we just said a quadrilateral, we divided it into 2 triangles. Well, then if we take 2 here, hey, that's all we need. We only need 2. Yeah, I could take this and I guess I could go like this. I could have 4, but the smallest amount of triangles I need is just 2. Awesome. Now for your secret hot question of semester 1. Let's get it together, guys. Let's do it really well this time. Okay. What type of shape is below? So if we look at the shape below us, what do we call it? What's its proper name? And what type of triangles make up the shape below? So not just how many, but if you think back to the semester before and when we classified triangles and talked about equilateral and isosceles and acute and right, well, what type of triangle is the one below? See you tomorrow, guys, and have a great evening.